All right, we're looking at A22. It's a warm-up. I just want to remind you of this. When I look at problems like the square root of 700, the square root of 99, I'm really thinking about what numbers on my perfect square list go in. Anytime you're in hundreds, I'm thinking 100. So the way you're going to break this down is going to be perfect square first, square root of 100 times square root of 7. 100 times 7 is 700. Break this down. The square root of 100 is 10. Keep the square root of 7. Okay, I'm going to let you do those next couple in a minute here. We want the biggest perfect square. What I want to do is flip it over because I want to remind you of some of this equation solving. We haven't done this, so here comes some old algebra back to you. So I want to start one of these with you to remind you. I think I'm going to go down to number 3, and then you're going to work on these. So we haven't done equation solving in here. I have a rhyme, cross the line, change the sign. The first thing you would do is clean up anything you can on the left, clean up the right, and once it's cleaned up, you're going to start isolating the x. So what would you get rid of first? Because I want to get x by itself. Would I get rid of the 3/4 or the -7? I would get rid of the -7. Now, remember your order of operations. Please excuse my dear. Yeah. I put them in this order: parentheses, what's in parentheses, exponents, multiply, divide, go from left to right. So you might divide first, same with add, subtract. We're going to do our order of operations backwards because I gave you the answer, you're finding the problem. So get rid of addition, subtraction first. So get rid of the -7, cross the line, change the sign, go from subtraction to the inverse, which is addition. And the idea is if you do something to this side to get rid of it, you have to balance it on that side. So I have 3/4 times x equals 15. Now I want to get rid of that 3/4, and I know it's a fraction. I'm not worried it's a fraction. It is multiplied by 3/4. Agreed? So what's the opposite of multiplication? Division. So if you want to, you could divide both sides by 3/4. Now I prefer not to do that because I don't use a calculator. But something divided by itself is 1, so I get just x. And then in your calculator, take 15 divided by 3/4. So if you're using your calculator, 15 divided by, and I'm going to do 3 fraction 4. If I don't use my fraction key, I need to use parentheses. And I should get 20. Now, if you can take a minute and go back to your elementary school math skills, instead of dividing by a fraction, we should multiply by the reciprocal. So me personally, I would have looked at this as 15 over 1, and I would have multiplied by the reciprocal, which is 4/3, and then I would cross cancel, and there's my 5 times 4 is 20. So that's a little fraction work. All right, number 4, what would you do with that? What should you do first? Yeah, I'm going to subtract the 6 first, cross that line, change the sign. And I get m over -5 equals what? 25? Now what? Yeah, a lot of people get stuck here, but if you think about it, it's m divided by -5. So I'm going to multiply both sides by -5. And this really does cancel out. And I end up with m equals -125. All right, now I'm only leaving 2 for you to do on your own. Let's do this last one together. What do you want to do with this one? It's a little bit different. Like in this one, we got rid of the addition subtraction first. The addition's up here. What should I get rid of first, the 4 or the -2? Yeah, I'm going to have to do that. You almost treat this like it's in parentheses. It's a given. When you have a fraction, these are in parentheses. So you guys are right. I have to multiply out the -2 first. So I'm not distributing this 2. I'm doing that to cancel it. -2 divided by 2 is 1. And I'm left with r plus 4 equals, well, negative times negative is going to be a positive 34. Now my goal is to get r by itself, so my last step is to what? Subtract 4. So I get r equals 30. Okay? All right. So